Hi everybody, Bill Sky, the Assembly Guy, and this is video number 2 of my File.io series in assembler language. And this one is going to be on Linux. So we're just going to jump right into the code. We're going to create some files. We're going to look at their contents. We're going to save strings. We're going to save numbers. We're going to reread them into memory. Let's get to it. All right, so I already have a project set up here. I'm just going to do a 32-bit project. And I think in the video notes, I'll put in the differences between 32-bit and 64-bit. Maybe we can get to 64-bit here as well today, but let's take a look. So let's take a look at our 32-bit assembler program, and this is just a basic assembler program template. And all I'm going to do is I just want to write some data. I just want to write some data out to memory or out to disk. So what I'm going to do is I'm going to create a variable called, I don't know, some string, and this is some string data. Now it's extremely important to make sure that you end it with a 0, not so much on just the data that you're going to be putting out, but especially on the file name. So if you create a variable called file name, which we do need, and let's just call it some data.bin. We're going to call it .bin for a reason you'll see in a little while. I'm going to put a ,0. Now it's very important that you put a ,0 here because the function that actually creates the file needs that 0 to know where the end of the file name is. If you don't put that 0 at the end, it'll just keep using data until it gets to a 0 for the file name. So it's very important to put that there. On here, it's not really as important. In fact, we might want to leave it out on the basic data, but we do want to say length of, because we need to be able to tell the assembler just how much data, how many characters we're going to be writing out. So this string is what we're going to be writing out to the file, and this is going to be the file name. So, okay, so what we're going to also need is we're going to need what we call a handle. A handle is simply a pointer to a file, and if you've ever done this in C or C++, even Java, if you create a file, you need to have some kind of a variable to contain the file that you've created. So I'm going to call this one output file handle. And for 64-bit, it should be defined quad. For 32-bit, it's defined double. And since it's in the BSX section, we're going to say reserve double 1. All right. So we're well on our way. Let's go ahead and build it. Make sure I didn't type something stupid in there, and I didn't. Okay, great. Okay, so the first thing that you need to know in a file, when you're processing files, there are basically 3 things that you do when you process a file. And let's actually put that in comments here. Number 1, you open the file. Think of it just like opening a book. You're opening a file. But in this case, what's different from a book and a file is that you specify if you want to open it as output, input, or output and input. So we're just going to open the file for output. 2, we want to write data to the file. And 3, we want to close the file. Now, a lot of people will say, well, you don't really have to close the file. The program will do it for you. That's not true. Because the way that it works is that when you write data to a file, you're not actually writing it to the disk or the SSD or the thumb drive. What you're doing is you're writing it to a memory area called what I like to call a file output buffer. And then the operating system decides when that output buffer is filled, I'll go ahead and write it out to disk. Now, you're not going to see that when you're writing small little pieces of data, but when you're writing a lot of data, the more data that you're writing, the more the output buffer is going to grow, and the more data you could lose if you don't close the file. So it's extremely important to close the file. So the first thing that we're going to do is we're going to open the file for output. Now, we already have the file name up here, 0 terminated. So let's go ahead and do that. I like to do it right underneath the comments. So to open a file, to create a file, I'm going to move into EAX 8H. So what that means is create the file. Whether the file's there or not, it's going to create it brand new. So it's something you want to be a little bit concerned about. If you think the file is already there, you may not want to use this. You may want to use the append feature, which we may be able to get to. But for right now, we're just going to create the file. The next thing we want to do is we want to move into EBX the address of the file name variable. So there's file name. So we're not going to put it in brackets. Remember, this is Linux, so I'm just going to say file name. And then what we want to do is we want to move the file attributes. Now these are the octal, if you watched, and I hope you did, if you watched my file system video where we talk about in Linux, we talk about the owner, the group, and the everybody else attributes, the octal attributes. Remember the RWX, those kind of things. You want to specify those in here. So what we're going to do is we're going to move into ECX 1C0H, and these are the file attributes. And you could do those in octal. So let's say if we want it to be only the owner that has access, we're going to make it 700 octal, an O at the end. Okay, now with that, we're going to say interrupt 80. So we're going to tickle the kernel. All right, so that should open the file. Now, what I'm going to do is I'm not going to bother closing the file. Well, actually, let's close the file. We really need to close the file. So to close the file, you pretty much do the same thing. What you're doing is you're just moving data into registers and then calling interrupt 80. So to close the file, I'm going to move into EAX 6H. 6H stands for close the file. And then you want to say move into EBX, the output file handle. What file we will be closing. Now, we have a little bit of a problem here. We did create the output file handle variable, but we never put anything in there. After you create the file, what's going to happen is EAX is going to contain the output file handle as a return. So we're going to move into output file handle EAX. And that should be it. That should open the file, create it, and then close it. So let's go ahead and build this. All right, and now let's run it. Let's just run it. Just assume it's going to work. Oh, don't want to make it. Oh, look what we've got. Some data.bin. So it did create the file. I'm on ls-al, and you can see that some data.bin has 0 bytes in it. It's an empty file. Awesome, that's great. Okay, so wow, you created an empty file. All right, now let's go ahead and write some data to it. Now to write data, it's pretty much the same whether it's text data or if it's an integer or a float, and we're going to do both of those. We have a thing called some string. We're going to write that to the file. So in between the open and the close, or the create and the close, we're going to do a write. And to do a write, we're going to move into EAX 4H. This is write to the file. That's what 4H stands for. Then in EBX, we have to do the same thing that we did for the close. We have to put the handle into EBX. Sith. Too much Star Wars. Okay. Now you have to put in the data that you want to write to the file, the address of the data. So we're going to move into ECX, some string. And then after that, we need to specify how much of the string. So we're going to put into EDX and then we're going to interrupt 80. I'm just going to copy that because it'll also copy the comments. Okay, so we're just going to go ahead and write to the file. Let's build it. Okay, what did I forget to do here? Sumstring.length. Oh, I typed it wrong. So it should be length with a G. Still got a problem. Maybe I didn't put a period or comma there. There we go. So I put a period instead of a comma. All right, so it built. Let's run it. Okay, here's our sum data. It now has 24 characters in it. Wow, we've actually got some data. I'm going to type cap sum data.bin, and we can see this is some string data. Also notice that the prompt for the bash window is right after it. There was no end line on that. And it's actually a good idea to not do that until you're ready to close the file. But we could do a thing here. I could create a string called endl, define byte, 0h, 0dh, 0. No, we just leave the 0 out and say .length of. And then let's go ahead and write endl so we get that nice, so the prompt isn't right after the data that we output to the screen. So I'm just going to copy this. And instead of some string, we're going to say endl. All right, let's save and build that. Let's run it. It's no longer 24, it's 26 characters, so let's cat. And you can see now that the cursor, instead of it just sitting right here, right after the data was printed on the screen, the actual prompt goes to the next line because we put that 0AH, 0DH. Now, if you want to look at that data using a hex editor, I love, is it khex? Nope, it's not khex. Let's see if I can find it. Ghex. Oh. So let's make ghex. And we can actually look at the data, and you can see the ASCII characters printed out here. And you can see the 0AH and the 0DH, which is the new line character. Okay, so that's a string. Now, something else you want to think about when you're writing out things to the file, you want to check to make sure, first of all, that the file opened okay. So before we create the file, or after we create the file, we want to compare EAX with 0. Jump if equal to error open. So if it equals to 0, then you've got an error issue. Something happened, it did not actually work, the open. So we're going to come down here and we're going to say error open. And we're just going to put a no op there for right now. And we're going to jump around that to end it all. That doesn't sound very good. And let's stay with the camel case. Otherwise, I'm going to get myself in trouble. Consistency is very important. All right. You really want to do that with everything. Even when you write stuff out, you want to make sure that it's equal to 0. So what's going to be in the right is you're going to have a problem, or you're going to, after the write is done, EAX will contain the number of characters that were written. So I'm going to compare EAX with 0H, jump equal. Instead of error open, let's just say error write. Oh, we have to do that after the 80. There we go. And you might want to do that with all of your writes. So that was error open. We're going to do error write, no op. Because we don't want to display multiple error messages. So EAX will always contain the number of characters that were written. And EAX will also never be 0 because it will contain the handle of the file when we open it. So that's string data. What about if we want to write a number to the file? Well, what I'm going to do is I'm going to leave this create open there, and I'm going to comment out all this code here for writing a string because I just want to write some numbers. So let's go ahead and then copy that. And maybe I shouldn't have commented it out right away, but what the heck, I like pressing the delete key. Okay, instead of printing a number, or instead of printing a string, we can print a number just as easily. So I'm going to come up here, and inside of my data section, I'm going to create some numbers. I don't know, what do we want to create? Int data 1, define double, 1, 2, 3, 4, 5. Int data 2, define double, 6, 7, 8, 9, 0. So just some data. We're just going to be printing some data or saving some data to a file. And you do it just like you do writing a string, except you specify the address of your integer data or your numeric data, and then you specify the length. Now you could do a .length of for each one of those variables, but you could just also hard code a 4 because we know that an integer is 4. So I'm going to go ahead and build that. I'm now going to run it. And our sum data is only 4 characters wide. Well, that's because we said only write 4 characters. Let's go ahead and cat. And you can see some strange data there. And that's because those are not ASCII characters. So the number 4 or the 1, 2, 3, 4, 5 in binary, the nibbles do not come out to, or I shouldn't say nibbles, but the bytes do not come out into ASCII format. So what we can do is we can say ghex sum data bin, and you can see here is 1, 2, 3, 4, 5. That's why we did it in hex, so we could easily look at it. Now it is going to be write justified, but also it is in little endian order when you look at the bytes. I believe if we go to long words, let's go to words. Let's see what we get. Yep, I think we should go to long words. You see 452301, but it's still in little endian order because it's looking. This particular hex editor looks at it the way that it's actually stored in memory. So it's little endian order right now because it's stored actually on the hard drive or on the file. Okay, so that's writing data to a file. Now, okay, it's fine to write the data to a file, but how do we now read the data from the file? So what I'm going to do is, since the data is already there, I'm going to comment out all of this code where I created the file, because I'm no longer interested in creating the file. So I'm just going to comment it out. And now I'm going to read from the file. Now, when you read from the file, it's exactly the same as it is when you write from the file. You, 1, open the file for input only. 2, read from the file. And 3, close the file. So we already have the close code up here, so let's go ahead and copy that and uncomment it. Now, instead of using the output file handle, I'm going to create another one, another variable up there called input file handle. So let's go ahead and do that. Oops. Having problems with my fingers today. All right, there's my input file handle. And I actually, because you can have a file, one file open for input, another file open for output at the same time. So you might have multiple of these file handles. And really they're just file pointers. Okay, so that's the close. Now we haven't done the open yet, so let's go ahead and do the open. So to open a file for input, you move into EAX 5H. You move into EBX, the file name. We're going to open the same file that we created the last run. We're going to move into ECX, the access specifier. Now, you don't really need that for reading files, but I always like to put a 0 in there. That's those octal. And then we're going to interrupt 80. Now, what's really important is that you check EAX, especially when you open a file, because what if you had the user type in the file name and they typed it in incorrectly? You definitely want to check it. So we're going to compare EAX with 0, jump if equal to error open. And then we're going to go ahead and just close the file. Now, I do want to show you the attributes that when we created the file, 700 octal, notice that the owner has complete authority. The group does not, because that was a 0, and everybody else does not because that's a 0. If you want everybody in the universe to be able to do anything they want with your file, then you would do that as 770 and as a reminder, or 777, and as a reminder, there was that setting in ECX when we created the file. But because you're opening it, you really don't have any reason to put anything in the access specifiers because those are already set. Okay, so I would like to show you how this works. I'm going to change some data.bin to some data.1 or some data1.bin, and I'm going to show you how this error checking works. So in the debugger, I'm going to put a breakpoint. Oh, right here on our first move when we open it for read, and let's go ahead and see what happens. It tries to open it, compares it with 0. If it's equal to 0, it jumps to error open. Whoops. No, it didn't. What happened? Oh my goodness, it's the difference between Windows and Linux. Look what it did. It actually made it a negative number. So it's not 0. It says, is it a negative number? That's awesome. So let's go in here. Instead of equals, we're going to say jump if below. So if EAX is less than 0, jump. Let's try that again. And it jumped. Or did it jump? No, it didn't. Let's take a look at the registers. It's showing as a -2. Oh, that's because B below is unsigned. So we have to go and do a less than. I love making these mistakes. Okay, let's run it. This is a good example of how important it is to use the, there you go. Now it was an error open. So now it jumped. All right, so we opened it, and now we didn't open it because there was an error, so because we had it misspelled up here. So let me go ahead and take that out. But we know that our error code works. All right, so now let's read from the file. Now we've got 2 numbers in there, okay? So what I'm going to do is I'm going to move into, what was it? Int data1. I'm going to move into int data1, a D word. So I'm going to 0 those out. The reason I'm doing that is because in the debugger I want to show you the data as it's read from the file. So I'm going to move into int data2, a D word 0h. We're just clearing those out because we saved them to the file, right? So why should we care? Okay, so now let's read the data. So we're going to move into EAX3H, read. We're going to move into EBX, input file handle. Nope, I just remembered. I never saved it. I never saved that handle. So I'm going to move, right after we open it, input file handle, EAX. Okay. All right, good. Figured that one out. The next thing we want to do is we want to move into ECX the location, the address of where we want to read it, where to read the data into, and we're going to move into EDX 4 because that's the size of an integer. And then we're going to interrupt ADH. Go ahead and just copy that. Okay, let's do the same thing for integer data 2. So we're going to read both those numbers back into memory. Okay, what's it saying? Move in integer data 0. Well, let's do this. Let's say move, maybe we have the D word wrong. Maybe we have to have the D word there. Nope, what did we do? Let's make sure we've got that correct up here. Int data 1 and int data 2. Oh, I know why. We forgot to put the square brackets around it. We're trying to move the data into an address. So instead of dereferencing it, we're trying to overwrite the address, which is not legal. There we go. Now it works. All right, now we're not printing the data off at all, so we're going to be debugging it. And I'm going to come down here and read. Okay, so I'm going to go to memory, and I'm going to do a search for in data 1. There it is, 1, 2, 3, 4, 5, and here's 6, 7, 8, 9, 0. That's in data 2. Step over. Now I'm just zeroing them out. And we've already opened the file. So now we're going to read from the file. Watch what happens when I do the int 80. Watch what happens at this very first 1, 2, 3, 4, 5. It read the data from the file. Let's read the second one. Oh, what happened? What happened? Something happened. It did not read it back into here. It should have read it there. If we put a 3, input file handle, int data 2 is in ECX. We put 4, oh, did we do the int 80? So after some checking, I found out that the file actually only has one number in it. So the read worked, it just hit the end of file. So why did that happen? Well, there's something going on here in this code. Let's go ahead and recreate the file. We don't want to write the string. We're going to write the numbers. So we don't want to write the string or the end L. So there's our, oh, we never wrote the integer data 2. Thought we did. Okay, so let's go ahead and do that. Now you could do this in two separate programs. You could create a menu to test all this. For right now, we're just going to do comments. There's my close. Okay, so let's just recreate the file this time. 8 bytes. All right, there it is, 8 bytes. Let's cat it. Okay, we've got 8 bytes in there now. Okay, good. So now we can go back and re-comment out the creation part. Let's comment out the write. of those two numbers, because all we're going to do is read from now on. And then let's uncomment the reads. And don't forget to close the file. All right. Make sure our breakpoint is the right spot. All right, let's go ahead and put that right where we zero out those variables. There's my int data 1 and int data 2. Let's zero those out. Let's go ahead and now read the first number back into int data 1. There it is. Let's read the second number back at int data 2. There it is. Phew! Thought I had done something wrong. And then we're going to go ahead and close the file. And then end the program. So it's really important that as you're doing this coding, you work with the file system and you take a look to make sure that what you think you're doing, you are doing. Now there's another way that you can read and write to and from a file, and that is to append it. But we're going to do that in another video where I show you how to open a file for append. And what you do is you open it for output, not create, but you open it for output. You position the right pointer all the way to the end of the file, which we're going to be talking about in that video, and then you start writing at the end. But until then, hope to see you at our next video.